Yes, yes. The second problem, now let us say the second problem related to this JEE mains, okay, session 3, July 20th to July 20th, and shift 1. The second problem, we already discussed about the first problem. Now, it's a wonderful problem this here. A greater than 0, A is any real number, it's a positive. Integral 0 to A, e power x minus step x. We already know x minus step x is nothing but a fraction part of x. Step x is an integral part of x. When you remove integral part from x, the remaining is only a fraction part. So indirectly he says that e power fraction part of x dx, this value is already given 10e by 9. Then what about this a value? Then what about this a value? This a value is equal to a 10 minus log of 1 plus c, then a equal to how much? The problem is like, then a equal to how much? Any one of the 4 options you need to identify. Yes. So let us see how you can solve this one. This is nothing but e power x minus step x. Yes, let us see the solution for this. Yes. So integration 0 to a e power is nothing but x minus step x. No doubt. Yes. Now I can write this one as e power x into e power minus step x. I can take, no problem. Or otherwise a small okay, a simpler thing is you write like this one, no problem, x minus step x only dx. A is a real number. So a is any real number means it is always after a positive integer. No doubt a is a positive number here. That means a real number is always a positive integer. It should cross. If it is an integer, no problem. Right. If it is 3.5 means it should cross 3. Am I right? It should cross 3.5. Okay. So every real number should cross at least one integer. You don't know that integer. A is a real number, he says that's all. Since we are dealing with a step x, it is an integral part, we need to identify the integer here. So let me explain. Let us suppose that a just crosses an integer, or it may be an integer. No problem. Yes, now I can write this one as integration 0 to n. Yes, I don't know which integer part it crossed. E power x minus step x dx plus integration of n to a e power x minus step x dx. This is what we got. So integration 0 to n e power x minus step x and n to a like this you have. So we already know this is nothing but a fraction part of x. We already know integration 0 to n x minus step x is nothing but a fraction part of x plus if we take this one integration of n to a e power x minus step x dx. We're having that. Let's let me explain. So step x, I mean fraction part of x is always a function whose period is 1. We already know. If you draw the graph of fraction part of x, it is always like this only. It is a discontinuous for every integer. And again it starts at 1 and it is also discontinuous. Again it starts at 2 and it is discontinuous and continuous like this. No, no. It is called the fraction part of x. So for every integer, the graph repeats. That means the fraction part of x, the period of the fraction part of x is always equal to 1. So we have a property of the definite integration. So I can write n into 1. I can write n into integration 0 to 1. If you take 0 to 1, if you take it is always a fraction part of x. Is always it is straight line y equal to x line. It's always like y equal to x only. Therefore 0 to 1, this is a line y equal to x. Therefore fraction part of x is nothing but e power x dx. And also plus integration of n to a e power x minus step x dx. You're having that. Just let me explain how you can do this one for the steps. Okay. So I'll explain again. Yes, here. So it is simple. It is not simple, but you can do it. Okay, without any difficulty. Right. E power x minus step x. So e power indirectly says that I want integration 0 to a e power fraction part of x where a is any positive real number. If a is an integer, no problem. If a is not an integer, every integer is a real number, no doubt. For suppose we have 3.5. Let us suppose a is 3.5. That implies you should cross 3 and you should cross the integer 3. That's why you should take, let n be an integer. Let us suppose n be an integer in which just a crosses the integer. Let us suppose it is 0 to m. Okay, this is e power x minus step x plus n to a. I can write the integration, no problem. Like this, I can move right now. So if you see, fraction part of x is always a periodic function with a period 1. If you see the graph of this one, like this you have. So for every integer, it again the graph repeats, and also it is a discontinuous. There is a hole for every integer. Okay, so it is always a fraction part of x is such a function whose graph repeats again and again for every integer. Therefore, its period is 1. No doubt, since its period is 1, you already know there is a property of the definite integration. Integration 0 to nt is equal to n into integration 0 to t, if t is a period of the given function. Here is a fraction part of x. Its period is 1. N into 0 to 1 e power x dx, like this you got here. Right. On further simplifying this part, what happens? Yes, here. On further simplifying this one, you'll get n into e power x dx. Integration is e power x. Apply the upper limit and lower limit. That is e power 1 minus 1. Get like this. Plus, if you see this one. So integration n to a e power x minus step x. You need to go for this one. So let us see how you can do this one. Yes. No doubt. If you take n to a, that implies n is 3 here. Let us suppose 3 and a is 3.5. Yes. 3 to 3.5, the step value is always 3. I'm right. Step value is always 3. I'm right. So here also, integration n to a, its step x value is always n. Yes, you'll get like this. Integration n to a e power x minus n dx. You get like this. E power x minus n dx. Right. You can simplify this part here. N into e minus 1 plus, this is an n. This is an n. So, then no problem. So, e power x minus n is always e power x minus 1 integration only. Even when you apply the upper limit, you'll get a power a minus n minus of e power n minus n, that is e power 0. This value is 1. So, if we solve this integrating value, this integration of this one is nothing but n into e minus 1 plus e power a minus n minus 1. So, this is the value. So, this value is already given as 10e minus 9. On comparing, you'll get both n value and automatically you'll get a value very easily. Get like this. Now let me explain. Okay, now see. If I write like this, what happens? Right now we have n into e minus 1, yes, plus e power a minus n minus 1 is equal to, you give like this, 10e minus 9 you get. Now, let me explain. If you, on comparing, you see, I can write it as 10 into e minus 1 plus 1 I can write. Am I right? Minus 10 plus 1, I can write like this, because 10 into e minus 1 plus 1. 10e minus 10 plus 1 goes to this one. On comparing this one, when you compare this one, this in the place of n, you're having 10. So I got n equal to 10. No problem, n equal to 10. I want to equate this value should be equal to 1 only. No doubt. So that means e power a minus n minus 1 should be equal to 1. Right. Now, so we already got n equal to 10. A minus 10 is equal to minus 1. If it goes like this. So now a minus 10 is equal to log 2 base e. So a is equal to, simply we get log 2 base e plus 10. So this is the value. So 10 plus log 2 base e, this one is 12. So when you know the graph of, that is a period of fraction part of x, and a simple application we can do is very easy. So it's a wonderful question. A is greater than 0. He says that a is a real number. Moreover, it is a positive real number. If a is a positive real number, then I want integration 0 to a e power fraction part of x. I want integration 0 to e power fraction part of x. That's a simple question here. So if a is a positive real number, right? If it is a positive integer, if it may be a positive integer, or it may be a real number which is not a positive integer, which is not an integer. For suppose 3.5 is there, is not an integer. Even if you take the 3.5, let us suppose a is 3.5, it should cross 3. It's the nearest integer. That's what I'm saying. I consider this n as a very nearest integer to a. It should cross. That's what I said. So integration 0 to a power x minus step x, I wrote it as integration 0 to n e power x minus step x plus n to a e power x minus step x. So whenever integration 0 to n e power x minus step x is nothing but e power fraction part of x. The period of fraction part of x is always 1. So 0 to n, if you simplify, you'll get like this, n into e minus 1 on simplifying, you'll get this value. And if you equate this value to the given value 10e minus 1, you'll get automatically a value that is log 2 base e plus 10. It is a simple and wonderful question. So simply he gave a is a positive real number. Find the integration of 0 to a e power fraction part of x. That's all. Is it clear? Pranay, you understood?